Hi there, welcome to this workshop on probability and counting. My name is Heinrich and I'm looking forward to taking you through some of the more interesting bits of probability and the fundamental counting principle today. Now, when we talk about probability, we're talking about something that is actually mathematical, and because it's mathematical, we can calculate it. So the probability of an event A is equal to the number of ways in which A can happen divided by the number of items in the sample space. So that's the number of ways A can happen divided by the sample space. And the sample space is just the total number of possible outcomes. So all the things that can possibly happen for this event A. Right, now remember, we have a very important equation when it comes to probability. And that is that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B happening together. And if we use alternative notation, we can use that union symbol there, that means or, and we can use the more rounded one there, that's going to mean and. But for the union, right, on a Venn diagram, the union is anything that is either in A or B. So it doesn't have to be in both. Anything that is either in A or B is the union of A and B. Whereas the intersection are those things that are only in A and B at the same time. So the intersection is that bit in the middle where they overlap. Now, if we have inclusive events, it means that there is an intersection. There is a bit where they overlap, where it's possible to be part of A as well as B. However, we do also have mutually exclusive events. And mutually exclusive events are those in which there is absolutely no overlap. So there aren't any data points that are part of A as well as being part of B at the same time. So for inclusive events, the probability of A and B is not equal to 0, and so this equation will remain as we've seen it. However, if we do have mutually exclusive events, that means that the probability of A and B is 0. There's no intersection between the two things, and so for mutually exclusive events, the probability of A or B is simply the sum of probability of A plus the probability of B. So we've got this important equation, and the question is, where does it come from? So here's the equation: probability of A or B equals the probability of A plus B plus A and B minus A and B. So we said that A or B is that part of the Venn diagram. So it's the bit that's only A, the intersection, and the bit that's only B. And that's equal to the probability of A plus the probability of B, and we said minus the probability of A and B. And you'll notice there that A and B is that bit where it actually overlaps. So if we take the probability of A, probability of B, and we write it such that we show that overlap, you'll see that when we add probability of A and B together, that overlap is going to be counted twice. So if we subtract the overlap, the intersection at the end, right, we're going to get what we're supposed to have, where the intersection is going to be counted only once, right? So once we subtract, we're going to have this, and then the left-hand side will in fact be equal to the right-hand side. So quickly pause the video and give this a try. Fantastic, well done. Let's see how it went, right? So here we've got to find some probabilities given some information. So the probability of event A is 0.4. Okay, so I'm going to write that here, PA equals 0.4, and the probability of event B is 0.5. PB equals 0.5. So we have to calculate the probability of A or B happening, right? So probability of A or B is that union. Okay, so you can write it as well as probability of A or B, like that. Okay, if A and B are mutually exclusive, I'm assuming it should say exclusive. Okay, so we said that when A and B are mutually exclusive, there's no intersection, and then A or B is just going to be the sum of A and B. So it'll be PA plus PB, which is then 0.4 plus 0.5, and then we get an answer of 0.9. Then it says, what is PA or B if the probability of A and B happening together is 0.2? So now we've got inclusive events, they can happen together. So in order to have the left-hand side equal to the right-hand side, we must subtract the intersection. And so the probability of A was the 0.4 plus the 0.5, now minus the 0.2, and that's going to give us 0.7. Okay, so well done if you got that.